Okay, so we're going to multiply two numbers in this tutorial, two whole numbers, the sort of problem that you're going to get in an exam, although it's more likely to be in the middle of a problem. It's going to be just something you want to do kind of on the side, get the right answer, and then go back to the problem using the result that you just got. So let's think of something like, well, 365 days in the year, so let's start with that, and maybe 12 months in the year, so 365 times 12, or 12 times 365. Now it's a good idea to have the larger number at the top, and we call the larger number the number that we're actually going to multiply, the multiplicand. Let's just write that down, multiplicand, and this is the multiplier. Okay, so the multiplier, you can try it the other way round, I should say, and it's well worth doing that. You don't have to reorder these. There's no reason why the multiplicand has to be at the top. It could be at the bottom, and you just multiply down, so that might work. But I think you'll see as soon as you do that it's easier. There are less steps involved if the smaller number is the one that we're multiplying with. Okay, well, let's start this process, but we're going to go left to right rather than right to left. And that's because we want to always try and get as close as we can to the way we think mentally, the way we calculate mentally, and the way we say things using language. So we say 365, we don't say 5, 60 and 300. So let's go left to right anyway and see what happens. Okay, so we're going to start with our multiplier, which has 10 in the left-hand area here. So we're going to start 10 times 300. 10 times 300 is 3,000. So we'll write that underneath. 10 times 600. 10 times 60 is 600. So we write that underneath. 10 times 5 is 50. Now we move to our ones place. So we've got 2 times 300 is 600. 2 times 60 is 120. And 2 times 5 is 10. So that gets us to that stage. I'm going to reorder these because the addition is quite tricky here. So we'll say 3,000 and 600, but I want to just line things up a bit nicer. So there's nothing wrong with just rewriting this just to make it look a bit neater and to see what we've got. And I can see more clearly now that we've got a lot of, we've only got 3,000, but we've got a lot of hundreds here, so we might have a bit of carrying going on here. So I'll do those separately. So we've got 3,000, write that down first, 600, 600 and 100. We've got 6 add 6 add 1, that's 13, so it's 1,300, and write that underneath. And now we've got our tens, so we've got a 20, a 50 and a 10, no carrying involved here. So 20, 50, that's going to be 80, and we've got no ones, so we've finished our calculation, 4,380. Fairly straightforward. Let's try it now going in the other direction then. Let's go from right to left, and this is the standard algorithm that we're going to use now. Most people would do it in this way, and I think we'll see why. Going then from right to left, we've got 2 times 5. So it starts off much easier than what we had here. So 2 times 5 is 10. We're going to write it down in columns, so we're not going to write 10 down like we did in the expanded method. We're going to write the 0 here, carry the 1. So in fact carrying 10. 2 times 6 is actually 2 times 60. So it's 120, but 2 times 6 is 12. Add the 1, we get 13. We put the 3 down, carry the 1, which is actually 100. So now we've got 2 times 300. 2 times 3, 6. So we've got 600. Add the 100 that we've put down here, and we've got 700. So 730 is our first line. Now we move to the left. We've got our tens now that we're going to multiply through. And again, we start with the 5. We don't start with the left-hand one. Start with the 5. So 10 5s, same as 5 tens, are 50. But what we're going to do is write 5 down. And we can put the 0 here in our ones column. But the important thing is we've got our 5 tens now. So 10 times 5, 50. 10 times 60, well, we think about it as 1 times 6, so we've got 6, and we write that down here. It's actually 600 because it's in the hundreds column. And we've got 10 times 3, so that's 300. Because it's, sorry, 10 times 300, and so we've got 3,000. So we write that in our thousands column. Okay, so it was a bit long-winded thinking about how to write this down because I wanted to make sure we weren't confused. Normally in the standard algorithm we'd just think about these automatically and not worry about whether they're tens, hundreds or thousands, which can get us confused. So now we're going to go right to left again. We've got 0, we've got 8, we've got 13 here, so we carry the 1,000 here, and we've got 3,000, add the 1,000, we've got 4,380. So we've got the same result, and it's going to be correct. We can check if it's going to be correct, because we could have made a mistake in either of these methods. We could have made a slip. And instead of doing these two methods to check, the best idea is to use estimation. So how are we going to do that? Mentally, we're looking at 365 and thinking, well, that's roughly 400. So we could do it that way. We could say 365 is roughly 400. And we can say, rounding 12 down, 12 is roughly 10. So we've got 10 times, let's write it down, 10 times 400 gives us 4,000. And so that gives us an estimation of the answer, and we know it's going to be in the region of 4,000. We also know, because we've rounded down here, and this was the multiplier, that it is going to be more than 4,000. So we can just sort of work that out and just think that we're roughly in the right area. So 4,380 is going to be right. We can't actually mentally calculate as an exact answer 12 times 365. We might be able to, but it's, that's a tricky thing to do. So we're using estimation just to check that we've got that we're in the right sort of area. Okay, so that's our sort of standard methods of multiplication, and you need to practice those to be fluent at them. I'm just going to finish this tutorial by thinking about a couple of other things. A lot of people grow up using algorithms and pictorial methods. The pictorial method that probably works best is called the grid method. And there are different ways that this is taught, but essentially they're the same sort of thing. And the other one is the lattice method, which is rather different. Let's start with the lattice method first. So I'm going to just draw a box and think about how we're going to use this box to automate our multiplication. So the way the lattice method works is you draw this box and you write 365 at the top. And on the side, we use the right-hand side for this, otherwise the number's going to get in the way. We write our 12, and we're going to write it, we can write it in any order, but usually we write it going down like that. So now we just multiply out, but before we do that, we've got to we've got to make our lattice. So let's just change the ink color here. You might want to use pencil, works really well for this. We're going to draw a diagonal. It's quite tricky. Helpful if you've got squared paper. But we draw our diagonals down just to give us an automatic way of totaling up the numbers. So what the lattice method does is it means we can avoid having to write all the numbers out in the expanded way that we looked at just now. Let's just get our ink color back. So we're ready. Now we can multiply out. So we're going to start with 10 times 5, but we're not going to think of it in that way. We're just going to use the digits here. So it's a digit value method. So 1 times 5 is 5. But instead of writing 5 in the lattice method, we write 0, 5. Then we write 1 times 6, 0, 6. And then we write 1 times 3, 0, 3. Now what we've actually done is write 365. But what the lattice is doing is it's going to shift us over to make this into 3,650. Okay, now we've got the next order to do. So we've got 2 times 5 gives us 10. 2 times 6 gives us 12. And 2 times 3 gives us 6. And we have to write that again as 0, 6. So now we add these up just as we did over here. And we'll see what these diagonals are doing. The diagonals are shifting us across so that our answer is going to be 10 times more than it was before. So let's see. So we'll start with this column here. So we've got a 0 in our ones column. So we write 0 here. We've got a 5, a 1 and a 2. So this is our 8. Okay, so we write 8 here in the tens column, giving us 80. Now we've got 0, 6, 1 and 6, so that adds up to 13. And as we did before, we put the 3 here, carry the 1. So it's exactly the same as what we were doing over here. It's just in this automated method now. And we've finally got, well, 3,000 is what it is, but we've got a 3 here. We carried a 1, so we've got 4, the digit 4 to write down here. So we've got 4,380. We've got the right result. So that's the lattice method. It's a long way from the expanded method or simpler ways of thinking about these things, and it can get us confused. But if you like using the lattice method, and if you've sort of grown up using it, then it works very well, and it's used especially in large parts of Asia. Very effective. The other method is the grid method, and the grid method is more intuitive. It's a visual method. You can think of counters behind it or an array of things. But essentially it involves drawing a box again, and this time we've drawn a box rather larger. We're not using the squares on our paper here. We're going to think about 12 here, and at the top here, let's just erase those lines from before. So we'll get rid of the lattice now. So okay, and we've got our, in fact, let's get rid of the whole of that. Let's get rid of that answer there. Give ourselves plenty of space and write 365 up here. So the idea is really rather like area. We've got a 365 dimension here and a 12 dimension here. we now split it up, and depending on how you've been taught, there are different ways of doing this. You might split it up evenly just to make an ordinary table with the same size sort of cells, or perhaps a more intuitive method is to say, well, 300 is about here, and now we've got our 60, and the 5 will be this bit at the end. So we've got 300 here, 60, and our 5. Over here we've got 10 and 2. So we're going to split it up into 10 and 2. And it doesn't matter what order we do it in. Let's think of the 10 as being this larger area here, and the 2 as this smaller area here. So we've got 10 and 2 makes 12, 365 at the top here. Okay, now we just multiply out. We've got 300 times 10, or 10 times 300, however we want to think about it, gives us 3,000. Now there's no place value here, so we don't have to worry about lining things up. We can just happily put these in the box, which we can think about as a good thing, or we can think, well, you know, this isn't practicing our place value. This isn't getting us to think about the very important idea of lining things up, which is our number system. But anyway, we've got 3,000 in this area now. We've got 60 times 10, so we've got 600. See if we can squeeze that in that area there. And we've got 5 times 10 is 50 to finish off that layer. So we've got 3,650. So it is the same as all these other methods. It's just that we're thinking about the calculation in a different kind of way. Now we move to our 2's. We've got 300 times 2, so we've got 600. We've got 60 times 2, which is 120. And we've got 5 times 2, or 2 times 5, which is 10. So as with the other methods, we've now got an addition, and we have to come out of the grid now and do this in, well, usually using a column method. So we would say 3,000, 600, 50, 600, 120, and 10. In other words, what we've ended up with is the expanded method here, and if we follow that through, we'll end up with 4,380, as we did over here. Okay, well, those are two fairly automatic methods, or visual methods, that we could use. One is very abstract, that's the lattice method here, and the other one is more pictorial. Both of them, though, are based on these methods that we used over here, so no different. It's just that these ones are just using numbers, not using these grids or boxes to line things up. So I hope that's helpful, and the rest of the tutorial will look at some of the ideas of multiplication that lie behind these methods. Right, well, I've pulled up an example of knitting here just to finish this video, because I think this helps us to think about what multiplication actually is. And that will help us think about what we mean by multiplier, multiplicand, and the result of multiplying a multiplier by a multiplicand, which we call a product. So you should be familiar with those three terms. Let's just think about our knitting, though. And instead of looking at the knitting straight away, let's just write down the sort of thing that we're doing when we're thinking about multiplication in this way. So we'll come to the knitting in a minute. We've got 3 little blocks here, and what I'm going to do is draw some more blocks, which we can think about as scaling up the area that was occupied by those 3 blocks. So we've just doubled the blocks, so times 2. We'll do, let's do 3 more here. So we've trebled the blocks, so it's times 3. And now, just to complete the pattern here, we're going to make, we're going to fit in another 3 blocks. So we've got the original 3 blocks has been scaled up by a scale factor of 4. Okay, so what it means is, or one of the ways of thinking about this is in the same way as we think in geometry about scale factors, times 4, the blocks or the area of the blocks occupied has got bigger, multiplied by 4, 4 times bigger, and so we say 3 times 4 equals 12, and that's the number of blocks we have. But the other thing we've done is we've created an array. In other words, we've created rows and columns. And the useful thing about this is that we can obviously add the number of rows. So we've got the number of rows is 3 and the number of columns is 4. So we could also think about an array in terms of length. So it could be 4 centimeters by 3 centimeters. But it's a useful way, isn't it, of counting large numbers by multiplying instead. That means take count of the rows and multiplying it by the count of the columns. So in the knitting example, what I'm going to do is just turn the knitting around. So we start with thinking in terms of rows and columns, but because we're knitting the same sort of stitch, if we turn it around, it can look exactly the same the other way round. And this makes the point, hopefully in concrete terms, that if we turn the row and column arrangement round, we've got exactly the same thing, which means that 3 times 4 is the same as, is exactly identical to 4 times 3. And this is what we call commutativity. We've seen already that commutativity, there we go, that addition is commutative, and so multiplication is as well. And we can express this algebraically as A times B is the same as B times A. Well, that's great, but it seems perhaps a little surprising then that there are still 2 different roles to these two terms in multiplication, and that's because we're not really setting out correctly here. Let's look at a different example and work on that. Here we've got hands, and the hands are made up of fingers. The result then of adding up all the fingers is 10. We'll have 10 fingers, and we've got bunches of 5s. So we've got 5, let's say F for fingers, so F plus another 5 fingers gives us our 10 fingers. Well, that's all pretty straightforward, and how does that help? Well, first of all, you might have noticed, by the way, that we use division before we even started to talk about multiplication. We divided our 10 into 5, or our hands do that for us. And so we're going to think, perhaps in a little bit more detail in another video, about the relationship between division and multiplication. If we divide something, organize it into groups, or start sharing, then that perhaps is a good starting point for thinking about multiplication. But before we go into that and look at how we can work with multiplication and division, let's just look at multiplication itself. 5f and 5f gives us 2 times 5f. Or in fact, we don't even need the brackets here, so let's just remove them. 2 times 5f is, let's just get our pen back, there we go. So 2 times 5f is 10f, and obviously, well, it is fairly obvious now, we've got 3 parts of our multiplication. So the first term here is our multiplier, and the second term is our multiplicand, and the final result of the multiplication is our product. And why are these all different? Well, the product is obvious why that's different, because these two operations, the operation of multiplication has combined these two to get the product, so the product's going to be different. It's the answer, it's the result. And we can see visually that the multiplier is just a number here, and the multiplicand is attached to the fingers, you could say. So these are very different kinds of things. If we were going to commute the 2 and the 5, we would still have only a multiplier and a multiplicand. We would still have this difference. We'd end up with, well, let's just use our eraser to make the point. So if we change this around, we've got 5 this time as our multiplier and 2 as our multiplicand, but we've still got these two different roles, you could say. The multiplier is doing the multiplying on the multiplicand, which is the thing that gets multiplied. Okay, well, I hope that's helpful in understanding what's actually going on with multiplication, and you might want to go on and practice a few more things, or you might even want to do a bit of algebra for yourself, just to make sure that you understand fully what's going on in the operation that we've been describing here, the multiplication. And also perhaps you might want to think visually about arrays and scaling up, scaling down as fundamental ideas behind multiplication. So